Hi all, today's topic is Laurent series for a problem 1. So the question has been given to be f of z is nothing but z square minus 1 divided by z plus 2 into z plus 3. Some condition it is given. First step, the question we have to apply a partial fraction and split the term. If it is given in the split the term means easily you can expand it using a Lorentz expansion. But it's not given in the split term, it's given like a partial fraction. First I will find the partial fraction and how we have to use this condition, how we are able to write the Lorentz expansion I will tell. So first step, partial fraction I have to do. The partial fraction for the given question. So z squared minus 1 divided by z plus 2 into z plus 3. The whole question I am taking. Partial fraction. So now when I have it, so how I have to apply a partial fraction in this means it is denominator only two terms. Only single fraction, single order. Okay. But numerator only constant it is there. Okay. It may be z or z squared. So when you have like this, but it is a quadratic term when you have it means what how to write, that is why I have taken this case of problem. Okay, so you will be stuck with this only partial fraction. So how I have to write it means when I have in the numerator, depending upon denominator only we write a partial fraction, but in this in the numerator also some quadratic term if I have it means how to write the partial fraction means for this I have to write only the constant a. Okay. For case of numerator, I have so like this quadratic term. So a plus denominator, remaining term for the denominator. So b divided by z plus 2 and c divided by z plus 3. This is the way for writing the given question. It's a different case of writing a partial fraction. That is why I selected this question. Okay, now same as usual, we will find the a, b and c constant I have to find. What is the rule? So I will write the LCM factor. So z minus 1. So a, it is not there. Both the factors are not there. So it is z plus 2 into z plus 3 plus b, it is only with respect to z plus 3 and c with respect to z plus 2. The denominator, whole denominator get cancelled. So I will write like this. Now I can find the value by randomly putting z equal to, put z equal to minus 3, I will get one factor, and z equal to minus 2 I will put, so I will get another one more solution. So now first this both I will put. So z equal to minus 3 when I put in this given equation, so this equation to be I will consider to be equation 1 when I put in this. So minus 3, so minus 3 is nothing but 9, 9 minus 1 8, 8 equal to, so z equal to minus 3, a will be cancelled, b will be cancelled, only I have to substitute in c. So c when I substitute minus 3 plus 2, so minus c. So C is nothing but minus 8. I'm getting the C to be minus 8 completed. Is it equal to minus 2 when I put same, A will be cancelled, C will be cancelled, I will be getting only B. So in this minus 2, it's nothing but 4. So 4 minus 1, so it is nothing but 3. So 3 equal to, in this when I put 1, so which I have to put, so minus 2 this cancel, B I will be getting 1. So B is nothing but 3. So we got B to be 3. Yes, two factors I have calculated. A now I have to calculate. So if I calculate A means randomly you put any data. So I will put Z equal to 0, I will get my A. Okay, so I will check. So now Z equal to 0 when I take it, minus 1 equal to 0 when I put means all I have to put 0 at z equal to 0. Here 0, here 0. So 6a. In this when I put 0, I will be getting 3b. 3b, no, 3b. So 3 only I will have it because I have calculated b. B is nothing but 3. In this when I put, so z equal to 0 when I put 2 plus 2 into c, so minus 8. So I will be getting a now. So a is nothing but minus 1 equal to 6a plus 9 minus 16. So a 6a, so minus 9. So minus 9, this 1 when it comes 10. So 6, again 6 I'll be getting. So a is nothing but 1 I'm getting. A to be 1. So all the three data is calculated. Now substitute in this. Substitute all the three data in this. A I have calculated to be 1. 1 plus B I have calculated 3 divided by Z plus 2. And C I am getting to be minus 8. So minus symbol I will write it here itself. So minus 8 into Z plus 3. For this only we have to write a Lorentz expansion. So now this is our f of Z. Now when I write a Lorentz expansion, so what is our condition given? First we come with our condition. So now rewrite f of z, the given costing to be, we have to write the costing to be 1 plus 3 divided by z plus 2 minus 8 divided by z plus 3 is our costing. Okay, so what is the condition given? According to the condition only we have to write. So what is the condition given means, it is condition to be given in the costing. It is 2 is less than z is less than 3. When you have like this in between data, when it is given, how to write it means, so first you take left, okay, then right. Okay, so how to write means modulus of z is greater than 2. I have to write. Correct? No? When I change the symbol this side, when I change it's greater. When I take only right hand side, modulus of z is less than 3. Both I have to write in terms of less than 3. So it is nothing but less than 3. I have to write it means when I write 2 divided by z, it becomes less. Correct? This divided by this, then it becomes the change in the symbol. So is less than. So this 3 also with respect to this, when I write modulus of z divided by 3 is less than 1. So this is our given question. Okay. So the condition, rewrite it according to this. So after writing, bring the term as it is in the given function. Okay. So I will try it, then only you can understand. See here what I am going to do. Bring the function means this is our costing. Okay. So f of z 1 as it is 1. I will not be able to write anything expansion of this. Okay, the Lorentz expansion. So now this is our costing. Okay, in this costing, okay, 3 by 2, 3 by 3. How I have to write? Okay, this I have to write in terms of z by 3. Yes, no, I'm able to write. This term you check, I have to apply this. In this, I have to apply this in this. Okay, how I have to write 3 divided by z plus 2. I have to write 2 divided by modulus of z. So I have to write it as it is means I have to take z only outside. Okay, z when I take, it becomes 1 plus 2 divided by z. Correct? 2 I will write like this. Then only you will not, z and 2 or seems to be same, divided by z plus 2. 2 I will write it like this. Okay. So now check in this costing. So now z I will take it outside. 1 plus 2 divided by z. Correct? So now 2 by z is applicable. Okay. Same way, when I come with this condition, 8 divided by z plus 3, I have to write z by 3. So z by 3 means I have to take only 3 outside. So 1 plus z by 3. So completed. Both the conditions are less than 1. So both I can apply it. The given condition to satisfy our given function, then only I can expand it. Okay. So this is the way I have to do it. So now when I write it, so it is nothing but 3, 3 by z, 3 by z. This 1 plus 2 by z whole power minus 1. Plus same way 8 by 3, this 1 plus z by 3 whole power minus 1. Completed, able to write. Now I can write the general format. So what is our general format? 1 plus 3 by z as it is. 1 plus x the whole power minus 1. 1 plus x the whole power minus 1. 1 minus x, that expansion you can write it. Because it is a Lorentz series, you can write the general format also. It's nothing but summation over minus 1 the whole power n, whatever that x, x power n. Okay. So now when I write it, it's a summation over minus 1 the whole power n. So x it is 2 by z, 2 by z the whole power n. So 2 I will write it this way. 2 by 2 by z the whole power n. Completed. Same way, minus symbol I left, you know. Yes, minus symbol it is here. Here also minus symbol will come. Okay. So minus 8 by 3. Now this also when I write it the same concept only. Summation over minus 1 the whole power n. So is at by 3 the whole power n. So completed. So this is our with respect to the condition given in the 2 is less than modulus of z is less than 3. With respect to this condition only we have expanded the Lorentz expansion. This is the way you have to do it for the Lorentz expansion. We have to remember only this case. 1 plus x whole power minus 1 is nothing but summation over minus 1 the whole power n x power n. But in Taylor's series, we'll write as per the formula, we will write it. Okay, that is also not wrong. After that, both will simplify it. You have doubt only when you told for in between terms. Okay, what happened when it is a single term? Okay, only when it is a single term. For example, when modulus of z greater than 3 or modulus of z less than 3, but I have a two factors, so it should apply for both the factor common term only. You have to use that condition commonly. That will be my next video. For example, okay, so if it is smallest of z, if it is greater than 3, okay, same question. If it is greater than 3, it is asked means it should apply for both. So first I will write this 3, I will have to make it to be less. Less if I make it means what if I do, it becomes less. 3 divided by modulus of z is less than 1. Correct? So this it comes modulus of z comes to this side, then greater than symbol becomes to be less 1. Okay, so 3 is less than is modulus of z. In this, what we have to do it, in that case, you have to take z outside. Okay, according to this, you have to write it. Same way, this as it is. You should not, because when it is 3 by z is less than 1 means, it is applicable for 2 by z is less than 1 only. Okay, 1 by z also is less than 1. Thank you.